already we have proved. And one thing you must remember these results. Therefore, log 4 to the base 4 will be 1. Finally, we get here 4 into 1, that is 4. Now 4 can be written as base is 2. We write it. The 4 is written like this, 2 square. That expression to be equal to k. Now powers are there, also product. Therefore, we take logarithm of both sides. Good morning. Welcome to B2S Academy. Welcome to my maths class. Today I am going to start new topic, logarithm. Already I have written on the board. Logarithm. Actually, when we discuss sums in calculus, derivatives, integration, frequently we need logarithm, but students feel uneasy. That is why I decided to discuss this topic, logarithm. Also, logarithm is associated to the topic laws of indices. That is why I shall first discuss laws of indices and then logarithm. That means logarithm and laws of indices will be discussed now side by side. First of all, laws of indices. First, let me discuss the symbols. A to the power n. A to the power n, meaning of A to the power n is product of n numbers of A. A is called base, n is called index, power, also exponent. Therefore, A to the power n is A into A into A. This is nth A. Next symbol n, A to the power n. N is the coefficient of A to the power n. Next, we shall discuss laws, symbols with meaning. Then laws. Number 1, I call it serial 1, now serial 2. A to the power n into A to the power n is equal to A to the power n plus n. We call it product law. A to the power n into A to the power n is equal to A to the power m plus n. Let me clarify. A to the power m into A to the power n. A to the power m already I have discussed. This is A into A into A into A. This is mth A, then A to the power n means A into A into A. This is nth A. Now if I remove the brackets, then how many A's are there? A into A into A. A, this is totally m A's are there. Here totally n A's are there. Therefore, in total, n plus n number of A's are there, which is expressed a to the power n plus n. If we know the reason why we get this result, then it will be quite easier to remember. Therefore, this is the product law. Then number 2, a to the power m whole to the power n, that will be equal to a to the power mn. Now why? Proof. A to the power m whole to the power n. Already we know a to the power n means product of n number of a's. Therefore, it is product of n number of a to the power m. This is nth. Now, as per this product law, product or multiplicative law, we will have the powers will be added. M plus m plus m. This is also nth m, and that is equal to a to the power. There are n number of m, therefore sum will be a to the power mn or nm. Next, number 3. AB whole to the power n, that is equal to AB into AB into AB AB whole to the power n, that is equal to product of n numbers of AB. Now, if we take all A's together, this is A into A into A into A. This is nth A into, we take all these together, therefore it will be B into B into B. This is also nth B. Therefore, this is expressed by a to the power n into b to the power n. Therefore, ab whole to the power n is equal to a to the power n into b to the power n. Now, we can take this corollary. Similarly, a by b whole to the power n is equal to a to the power n by b to the power n. All these three are related to multiplication or product. Therefore, this is the fundamental law of index. Fundamental law of index is this: This is called fundamental law of index. Then from that we get next one, a to the power m whole to the power n is equal to a to the power mn. Next we get ab whole to the power n, that is equal to a to the power n into b to the power n. Then a by b whole to the power n is equal to a to the power n divided by b to the power n. Next we have in case of division, a to the power m division a to the power n, which can be written in the fraction form, a to the power m divided by a to the power n, numerator a to the power m, denominator a to the power n, that is equal to a to the power m minus n. That is known as quotient law. A to the power m divided by a to the power n is equal to a to the power m minus n. We can also prove this. A to the power m divided by a to the power n, numerator a to the power n, that means there is product of m number of a's and this is product of n number of a's. Now if we cancel those like this, proof, a to the power n by a to the power n, a into a into a into a, this is mth a, and denominator is a into a into a, this is nth a. Now nth a will be cancelled from numerator denominator, then we will have finally a to the power m minus n. Next, number 2, a to the power 0 is equal to 1. That is definition, taken as definition. One thing that is to be mentioned, when a is base, a never 0. Note this one. A is non-zero. Now a to the power 0 equal to 1, that is taken to be true as definition, though we can explain that in case of real numbers, a to the power 0, where a is real number, a to the power 0 can be written as a to the power n minus n. Now, as per this quotient law, it will be a to the power n by a to the power n. Now, division of a number by itself, the result will be 1. In case of real number or rational number, we explain this law or formula like this, but actually it is taken to be true always, that is why definition. Next, number 3, a to the power minus n, that is equal to 1 by a to the power n. Proof is this one. A to the power minus n can be written as a to the power 0 minus n. Now, as per quotient law, it is a to the power 0 by a to the power n. A to the power 0 is 1. Therefore, finally, a to the power minus n equal to 1 by a to the power n. Next formula, nth root of a to the power n is equal to a to the power m by n. This is actually taken as this is index form, this is radical form. Nth root of a to the power n is equal to a to the power m by n. This is not quite new, that is just notation or symbol. For example, square root 2, that is equal to 2 to the power half, cube root 7, that is equal to 7 to the power 1/3. Next, number 4, if a to the power m is equal to a to the power n, where a is not equal to 0, then m equal to n if a is not 1. In case of a equal to 1, 1 to the power m, that is equal to 1, 1 to the power n, that is also equal to 1. Therefore, we cannot conclude about mn. Now, if a is not equal to 1, then we can say that a to the power m is equal to a to the power n will give m equal to n. Next, number 5, a to the power n is equal to b to the power n. Here powers are equal, then either n equal to 0 or a equal to b. If a to the power n is equal to b to the power n, then either n will be 0 or a equal to b. That means if powers are equal, then bases will be equal or those powers will be 0 each. These are the laws of indices. Logarithm is closely related to laws of indices. That is why I have discussed first laws of indices, then we move to logarithm. A to the power x equal to b. Equation form a to the power x equal to b, or b is the value of a to the power x. Here we consider the restriction: a is non-zero, b positive, a greater than 1. A to the power x is equal to b. Now, we express this index, then x is expressed by log of b to the base a. A to the power x is equal to b. B is the value of e to the power x. Also, if x be unknown, we can treat as equation. Then we express this index x by this form, x equal to log of b to the base a. This is definition. Now I replace this one here. Therefore, a to the power log of b to the base a is equal to b. This is the first formula. If you see these two are same, the value will be b. Remember like this. Next we have, if a to the power x equal to b, then if we raise to the power n both sides, then what we get, a to the power nx is equal to b to the power n. Therefore, I can express this in terms of logarithm. B to the power n is equal to log of b to the power n log of b to the power n to the base a. I can express that. Therefore, log of b to the power n in terms of logarithm, this one will be this. Therefore, log of b to the power n to the base a is equal to nx. Already we have got x, this one. Therefore, n log of b to the base a. Log of b to the power n to the base a will be equal to nx. Now substituting x by this one, we get this one. This is the next formula. Now we can use this definition. Take few examples. Three square is equal to 9. Now I can express this log of 9 to the base 3 equal to 2. As per definition, 3 square is equal to 9 means this one. Also, if it is given, then we can write this. Number 2, a to the power 0 equal to 1, from which we can write using the concept of logarithm, log of 1, and already mentioned a is non-zero, therefore log of 1 to the base a equal to 0. Also we can take this one, a to the power 1 equal to a, therefore in terms of logarithm it will be log a to the base a is equal to 1. Next we move to the laws of logarithm log of m plus log of n is equal to log of mn. We can also say reversely log of mn equal to log m plus log n. Here bases are not mentioned. If we mention the base, it will be like this: log of mn to the base x is equal to log m to the base x plus log n to the base x, product law. Then we have log of m by n to the base x is equal to log m to the base x minus log n to the base x. Then we have log of a to the base x is equal to log of a to the base y into log of y to the base x. This is called base changing formula. These are the three laws will be discussed initially. First, let me prove this one. For that, number one, let log of mn to the base x equal to p log of m to the base x equal to q and log of n to the base x equal to r. Now, as per definition, therefore x to the power p is equal to mn, and from this x to the power q is equal to m, and from this x to the power r is equal to n. Now we start from here. Now mn is equal to x to the power q into x to the power r, or x to the power p is equal to x to the power q plus r as per laws of indices. Therefore, from it we get p equal to q plus r. Therefore, putting the values of qr, we get log of mn to the base x is equal to log of m to the base x plus log m to the base x. Similarly, you can prove this one. I advise you prove yourself, learners. of 11-12 standard, you prove yourself this one. Now I prove the third one. Put let log of a to the base x equal to t, log of a to the base y equal to q, log of y to the base x is equal to r. Now from these three we get x to the power p equal to a. From this y to the base power q is equal to a, and from it x to the power r is equal to y. Now x to the power p is equal to a, also a equal to y to the power q. Now we have the value of y, therefore x to the power p, put the value of y, this will be x to the power r whole to the power q, and from laws of indices we have got this is equal to x to the power qr. Therefore we get x to the power p is equal to x to the power qr. Therefore p is equal to, bases are equal, therefore powers will be equal qr. Now putting the values we get log of a to the base x is equal to log of a to the base y into log of y to the base x. This is the base changing formula. Now putting a equal to x, putting a equal to x, what we get from here? Therefore log of a to the base a is equal to log of a to the base y into log y to the base a. Now log of a to the base a is 1, therefore log of a to the base y into log of y to the base a is equal to 1, from which we can write log of a to the base y is equal to 1 by log of y to the base a. This is deduced from this original one. If we put a equal to x, left side will be log of a to the base a, which is equal to 1. Therefore right side will be log of a to the base y into log of y to the base a, from which we get this one. Now again we can deduce from this one what we have got, log of a to the base y is equal to 1 by log of y to the base a. Now this one can be written as log Here base is a, therefore 1 can be written as log of a to the base a log of y to the base a. Now if we omit these bases which is common, therefore log of a to the base y is equal to log a by log y. Here we have omitted a. Thus we have discussed all the first three laws of logarithm. I shall work out few more sums on logarithms. Already I have written down 3 sums on the board. Good morning to all the viewers. Good morning to all students who follow my classes. Welcome to P2S Academy. Welcome to my maths class. I am continuing today the topic logarithm. Now I am going to work out sums serially. I shall start from left hand side and reach right hand side. Bases are 2, 2, then 4, 2, 5, 6 plus 2 log of 2 to the base root 2. First of all, we note 256 is there. We on the right side first find the factors of 256. Already we know 256 is equal to 16 square, that is 4 square whole square, that is 4 to the power 4. As base is 4, we keep this value of 256 log of base 2 log base 2 log of 4 to the power 4 to the base 4. In place of 256, I have written 4 to the power 4 plus, here I apply base changing formula like this: numerator log 2, denominator log of root 2. As formula, log of a to the base b equal to log a by log b. I have used here this formula: log of a to the base b is equal to, in the fraction form, where numerator is log a, denominator is log b. Already I deduced that formula in the earlier class. I have written here like this. Then log base 2 log base 2. Now log power form 4 log of 4 to the base 4 plus 2 into log 2. This is root 2 means log 2 to the power half. Therefore, as per this formula, log, say, x to the power a to the base a will be equal to log n log of x to the base a. I suggest students or learners, while you are working out sums on specific topic, better you write the results or formula you need on the right side of the page, or you can write those initially and do the sums. Therefore, it will be now these log 2's are cancelled. Log 4 to the base 4, log of a to the base a, I write here. Log a to the base a is 1. Already we have proved. And one thing you must remember these results. Therefore, log 4 to the base 4 will be 1. Finally, we get here 4 into 1, that is 4. Now 4 can be written as base is 2. We write it. The 4 is written like this, 2 square plus 2 half is there at the denominator. Therefore, finally it will 2 into 2, that means 4. We write on the right side. Now 2 square, log of 2 square to the base 2. This power will be taken in front as per this formula. Therefore, log of 2 log 2 to the base 2. You can skip this step also. Therefore, log of 2 to the base 2 plus 4, log of 2 to the base 2, that is 1 plus 4, that is RHS part, proved. Try to understand. First of all, this number has been expressed in the form of 4 or power of 4 like this. Then we have applied this formula and move on. Finally, we get 1 plus 4, that is equal to 5, RHS part. Hence, sum number 1 is solved. Now to solve sum number 2, I have this. LHS log of a to the base b cube into log of b to the base c cube into log of c to the base a cube. Now I apply first the base changing formula like this. Log of a log of b cube log of b log of c cube log of c log of a cube. Already I have discussed was base changing formula. Log of a to the base b, that will be equal to log a by log b. According to that formula, we have expressed each of these terms like this. Then we have log of b cube. Power is there 3, therefore it will be 3 log b, numerator log a, into 3 log c, numerator log b, into log c, 3 log a. Now we see log a cancelled from numerator denominator. log b cancel from numerator denominator, log c also cancelled. Therefore, 45 1 by 3 cube, that is 1 by 27 RHS root. In many cases, if you use the base changing formula, the sum will be easier. Now we have worked out two sums. Then sum number 3. Followers or students already have copied this one. I repeatedly mentioned that students or learners, while you follow maths classes, YouTube classes rather, always you take a coffee and a pen first. Then you start working out with the teacher. Now, number 3, LHS 1 by log of xyz to the base xy plus 1 by log of xyz to the base yz plus 1 by log of xyz to the base zx. Already I have mentioned in the earlier sum, first we change the base like this. It will be log of xyz by log xy. Denominator of the denominator is log of xy. Therefore, log of xy will be taken at the numerator. That means log of xy, log of xyz. I write here. Since log of xyz xy is equal to 1 by log of xyz by log of xy. Now 1 by this expression, therefore that will be, first term will be 1 by log of xyz by log xy. Now log of xy is the denominator of the denominator, therefore this will be log of xy by log xyz. I have used this one, plus log of xyz log of yz plus log of zx log of xyz. We find all denominators same. Therefore, addition as per the law of addition of fraction, LCM of the denominators, here it will be xyz, log of xyz, numerator will be log of xy plus log of yz plus log of zx. Now Already we know the formula log of A plus log of B, that is equal to log AB. We shall apply now that log of xy, yz, zx, log of xyz. We have applied here log A plus log B log of AB. Now what is the product? X square y square z square, log of x square y square z square divided by log of xyz. This is log of xyz whole square by log of xyz 2 log of xyz by log of xyz. These two cancelled, therefore finally we get 2. I think students have understood. In the first step, I have used the base changing formula, then these steps followed. Therefore, we have worked out first 3 sums today. Now, second set, 4 sums I will work out. Number 1, log of this one, that will be equal to 1. For solving that, first of all, I calculate the value of this one, this part. Since it is 1 and we find the base is 5, that means it should be equal to 5. So that log of 5 to the base 5, that will be equal to, as per formula 1, let we are calculating the value of root over 5 into under square root symbol root 5, again square root 5 to infinity. Squaring x square equal to 1 square root sign, that is outmost 1 will be removed. Now this one again product to infinity, that means this becomes 5x. As I have taken x equal to under square root symbol 5 into under square root symbol 5 into under square root symbol 5 up to infinity. Therefore, after squaring, we get 5 into again this part, that is x. Therefore, x square minus 5x is equal to 0. Now taking x common factor, x minus 5 equal to 0. From it, we can conclude either x equal to 0 or x minus 5 is equal to 0. From it, we get x equal to 5. Now, x cannot be 0 as square root of some positive numbers. Therefore, x is never 0. Follow that. Square root of 5 into again square root 5 into again square root 5 up to infinity. Therefore, square root of a positive number that can never be 0. But x is positive, therefore is equal to 5. We have got the value of this part. Therefore, left hand side is equal to log of 5 to the base 5 to the base 5 that is equal to 1 RHS proved. Very interesting one. I think you have followed. Why x is not equal to 0? I have explained that. First of all, this one is a positive number. Square root of 5 into square root of 5 into square root of 5 up to infinity. Therefore, square root of a positive number. Therefore, value of x is never 0. Now number 2, LHS log of 1 plus 2 plus 3. Now what is the sum? 1 plus 2 plus 3, sum is 6. Now 6 can be written as 1 into 2 into 3. Now I apply the formula log of AB is equal to log of A plus log of B. Log 1 plus log 2 plus log 3, that is RHS. I think students, learners have followed. Now I am going to work out sum number 3. Left hand side log A whole square minus log B whole square, that is of the form p square minus q square. Therefore, it is equal to log A plus log B whole into log A minus log B. P plus q into p minus q form, as it is p square minus q square. Now as per formula, this will be log of AB into log of A by B. This is product formula. Also we can call sum formula, conversion. Then log of A by log of A by B. Now this is the RHS part. This question may be asked like this. You express this expression as a product of two logarithms. You see, this is one logarithm, this is one logarithm. Therefore, the question may be asked like this. You express this as a product of two logarithms. Then you are to follow these steps. Now, I have taken one sum for calculation. First of all, I shall calculate log of 16 by 15, log of 25 by 24, log of 81 by 80 separately. Actually, if we write the whole, that will be a larger one. To avoid that, we calculate these three quantities separately first. Number 4. Now, log of 16 by 15, I apply this changing formula, log 16 minus log 15, that is equal to log of 16 means 2 to the power 4 minus log 3 into 5, 15 equal to 3 into 5, it will be 4 log 2 minus log 3 within brackets log 3 plus log 5. I remove the brackets and write it directly, this one. Then log of 25, 24, log of 25, log of 25 minus log of 24, that is equal to log of 5 square minus log of 24 means 8 into 3, that means 2 cube into 3. Therefore, this will be 2 log 5 minus log of 2 cube plus log of 3. That means it will be 3 log 2 minus log 3. I have calculated mentally. First of all, log of within brackets 2 cube plus 3, that is equal to log of 2 cube plus log of 3. Now, if we remove the brackets, it will be, since there is minus sign before the bracket start, therefore it will be this. Then log of 81 by 80, log of 81 minus log of 80. Now 81 is 3 to the power 4 minus log 16 into 5, 80 is equal to 16 into 5. Therefore, I can write it 2 to the power 4 into 5. That means 4 log 3 minus 4 log 2 minus log 5. To avoid the complication, I have calculated these three logarithms first, like this. Though it will be longer apparently, but it will be quite easier. Now, I put these values here. LHS is this 1 log 2 plus 16 into, already we have calculated those, 4 log 2 minus log 3 minus log 5 plus 12 log this one already 2 log 5 minus 3 log 2 minus log 3 plus 7 into this, 7 into this one, 4 log 3 minus 4 log 2 minus log 5. Now let us simplify. Log 2 plus 64 log 2 minus 16 log 3 minus 16 log 5, 24 log 5 minus 36 log 2 minus 12 log 3 plus 28 log 3 minus 28 log 2 minus 7 log 5. Now we see 64 log 2. First we consider log 2. Log 2, here is log 2 and here is log 2. 36 minus 28 minus 36 minus 28, that means minus 64. Therefore, these are cancelled. Then we consider log 3 term. 16 log 3 minus 12 log 3, that means minus 28 log 3, then plus 28 log 3. Therefore, these are cancelled. Then 16 log 5 negative minus 7 log 5, that means in this step we get log 2 plus 24 log 5 and these two minus 23 log 5, so that log 2 plus log 5 24 log 5 minus 23 log 5 log 5. Therefore, this is log of 2 into 5 that is equal to log of 10. Now, what will be the value of log of 10? I have not discussed that matter. Actually, in algebra, if there is no base, that means base is not mentioned. In that case, base will be 10, that is called common base. Therefore, it is log of 10 to the base 10. That means value is 1. Therefore, value of this one is 1, that is RHS part proved. Now, I have mentioned here base. When it is not mentioned in case of algebra, base will be taken as 10, which is called common logarithm or common base. When the base is 10, we call it common logarithm. This is introduced by John Brick. That is why we call Gregorian logarithm also common logarithm. Now I discuss this matter, basis of logarithm. First of all, common base, which is 10. Generally, in case of algebra, if base is not mentioned, the base of the concerned logarithm will be 10. Then there we have natural logarithm in that case base is e. Base is e, which is Eulerian constant already. Students of 11-12 have heard this. Base is e and its value is, it is an irrational number. It was discovered by Euler or Euler, and it is already I have mentioned irrational number. Generally, in case of calculus, derivative, integration, etc., the base of the logarithm will be e, and if the base be different from e, then we have to change the base using the base changing formula. Actually, all formulae or results in calculus have been formed with the help of the base e. In case of logarithm, I repeat it, in case of logarithm used in calculus, base will be e. This is called natural logarithm. And now we move to work out few more sums. Next, I have taken the third set. We call it third set, in which 5 sums are there. I shall work out these one by one. First of all, number 1. We have to show left hand side equal to 1, which is right hand side. I start like this. I take this whole expression as a new symbol, say k. Let x to the power log y minus log z into y to the power log z minus log x into z to the power log of x minus log y, that equal to k. As we cannot simplify with the help of logarithmic formula we have learned, that is why I have taken that expression to be equal to k. Now powers are there, also product, therefore we take logarithm of both sides. Therefore log k will be equal to log of x to the power log y minus log z into y to the power log z minus log x into z to the power log x minus log y. First of all, product. Therefore, as per formula, log of AB is equal to log A plus log B. It will be log of this one plus log of plus log of then log a to the power n form, that is equal to n log a, Therefore it will be log y minus log z whole into log x plus log z minus log x log y plus log x minus log y into log z. Then simplification after multiplication, log x into log y minus log z into log x plus log y into log z minus log x into log y plus log z log x minus log y log z. Large expression, you see log x log y cancelled, then log z log x cancelled, minus plus, and log y log z cancelled. That means what we get, I write here. Therefore we took logarithm log k equal to 0, and 0 can be written as log of 1. That is formula. Log k equal to log 1. Therefore k equal to 1. Proved. Let me repeat. First of all, I have taken this expression to be equal to k. Then I have taken logarithm. Why logarithm? Because powers are there as well as product symbols are there. If we take logarithm, then we can apply log of a b equal to log a plus log b, as well as log of a to the power n equal to n log a. I have applied those formulas, and we have got at the end step the large expression, each term of which will be cancelled. That is, finally log k equal to 0, which is equal to log 1. Therefore we conclude k equal to 1. Therefore the sum is solved. Now we move number 2 sum. Sum number 2. I rub this. Number 2. Product of these is equal to root over xyz. Therefore, I start like this, taking this one first and simplify. Now, log x to the base a square, log of this power, log of x to the base a square, I simplify that first, is equal to, as per this changing formula, it will be log x by log a square, that is equal to log x by 2 log a, which is half log of x to the base a. Therefore, a to the power log of x to the base a square, that is equal to a to the power half log of x to the base a, Already we have learned in the earlier class we use now the formula a to the power log of b to the base a is equal to b. We have learned earlier this formula log of a to the power log of b to the base a equal to b. Therefore, value of this one is nothing but root x. First of all, I have got the value of this part, and that value is root x. Therefore, similarly, or if we proceed in the similar way, we will get the value of this one will be root y, and the value of this one will be root z. Similarly, I mention here b to the power log of y to the base b square is equal to root y, and c to the power log z to the base c square equal to root z. Therefore, LHS is equal to root x into root y into root z. Therefore, product of these three will be root over x, y, z, that is equal to RHS. Proved. Therefore, I solve second one. Then I move to sum number 3. Now, sum number 3. First we note values of L, M, N are given. That is why we calculate first log L, log N and log N. You see, we need those values. That is why number 3 given L is equal to x, y to the power a minus 1. Therefore, log of L equal to log of x, y to the power a minus 1, which will be equal to log x plus log of y to the power a minus 1, that is equal to log x plus a minus 1 whole into log y. M equal to x, y to the power b minus 1. Therefore, log M equal to log of x, y to the power b minus 1, that is equal to log x plus b minus 1 whole into log y. Then n is equal to x, y to the power c minus 1. Therefore, log n equal to, I write directly following this, log x plus c minus 1 whole into log y. Now we shall put the values. I rub this one. this is left hand side, a into log of m by n means log m minus log n plus b into log n minus log l plus c into log l minus log m. A. Now values of log m, log n, etc. Now log m minus log n. If we put the values, you see log x will be cancelled. Since there is minus sign, these two will be cancelled. Therefore, we don't write here log x, as it is a large one. Then plus b log n minus log l. This one minus this one. That means c minus 1 into log y minus a minus 1 into log y plus c into log n minus log l. Let me see whether I have m minus n, m minus n, n minus n, then l minus n, l minus n. Okay. Then it will be a minus a 1 log y minus this one b minus 1 log large expression. You want to be present here. Then we simplify. If we remove the first brackets here, it will be b log y minus log y, and it will be minus c log y plus log y, so that log y will be cancelled. Therefore, we here just skip that step. A b log y minus c log y plus b c log y minus a log y plus c into a log y minus b log y. I have skipped that step, otherwise it will be longer. Just mentally we have calculated. After removing the first bracket, it will be b log y minus log y, and after removing the first bracket here, c log y minus log y. Since there is minus sign will be reversed in case of log y, so that log y's will be cancelled. After cancellation, the step will be this one. Now I simplify. ab log y minus ac log y plus bc log y minus ab log y plus ac log y minus bc log y. See, ab log y cancelled, AC log y minus here AC log y cancelled, then BC log y cancelled. Therefore, the value is 0. And that is the RHS part. As it is a long one, we have applied the trick. First of all, we have calculated log n, and log L. Then we have put the values, also skipping few steps. Finally, the value is 0. Thus, we have solved this one. Now, number 4. Number 4, LHS log of x to the base a divided by log of x to the base ab. Now, numerator will be log of x by log of a, applying the base changing formula, and it will be log of x by log of ab, that is equal to, since log of ab is the denominator of the denominator, therefore it will be taken at the numerator, so that it will be log x into log of ab by log a into log x. These log x's are cancelled. Then log of ab is there. It is log a plus log b by log of a. Now, applying distributive law of division, log a by log a, that is 1 plus log b by log a, that is equal to 1 plus log of b to the base a, which is the RHS part proved. From left side, we have used the base changing formula and reached RHS. Then number 5. Number 5, LHS 1 by log of 12 to the base 3 plus 1 by log 12 to the base 4. Better we calculate these two separately. First, now log of 12 to the base 3 is equal to log of 3 into 2 square to the base 3, that is equal to log of 3 to the base 3 plus log of 2 square to the base 3, that means 2 log of 2 to the base 3. And log of 12 to the base 4, that is equal to log of 4 into 3 to the base 4, that is equal to log of 4 to the base 4 plus log of 3 to the base 4. This is 1 plus log of 4 to the base 3, and this is 1 plus log of 3 to the base 4. We can write that as 1 by log of 4 to the base 3. As there is log of 4 to the base 3, I have written this one in this form using base changing formula. Therefore, LHS is equal to 1 by, for this one I will put that 1 plus log of 4 to the base 3 plus 1 by, for this 1 plus 1 by log of 4 to the base 3, that is equal to 1 by 1 plus log of 4 to the base 3 plus, after simplification it will be at the denominator log of 4 to the base 3, 1 plus log of 4 to the base 3. Therefore, LCM of the denominators 1 plus log of 4 to the base 3, 1 plus log of 4 to the base 3, that is equal to 1 RHS. Now in the next class I shall prove few more sums to finish the topic logarithm. Thank you.